Hey guys, welcome to our first lesson, and it'll be on the definite integral. Building on a few lessons that we've done before that haven't been put up yet. So, here we go. So far, all we've been dealing with is integrals such as this. If I say the integral from 1 to 2 of x plus 1 dx, or something like this, which would be the integral of x squared from 0 to 2 dx. Now the convenience about these is that we look and we draw it like this. This guy's talking from x equals 1 to x equals 2, and he wants that area. This guy over here is a parabola. Great, from 0 to, let's say, x is 2. Brilliant. Now what's been convenient about all of this so far is that all of these areas happen to be above the x-axis. So now let's look at what happens if they go below the x-axis. Let's take our basic example of y. Let's go minus 1 to 1 of x cubed dx. Okay, so we're going to draw this guy. We can just do a quick little sketch. Boom. E is x cubed, and I'm going to go from minus 1 to 1. I want these two areas here. If I were to do the integral, I'm just going to find the primitive here. By the way, I didn't bother doing it for the first two because we've done that before. That would equal x to the power of 4 on 4 from the bounds 1 minus 1. Sub 1 in 1 to the 4 is a quarter minus, now minus 1 to the power of 4 is just 1. So I get a quarter. So my answer is 0. Now this is a correct answer. Okay, there's nothing wrong with this. It doesn't say find the area. If it were to say find the area, I'm going to have to do that a little bit differently. Let's firstly look at this area here. That would be, just skipping to here, x 4 on 4 from 0 to 1, which equals a quarter. Now I can see that number here. That's fine, that's good. If I do it for the other bit, let's say this guy here, that would be x 4 on 4 from 0 to minus 1. Now note the larger bound is on the top there. There we go. And that will come out at 0 minus a quarter, which is equal to minus a quarter. Alright, so what this tells us is that if I do the integral, which is just a value sum, I will get 0, and that's fine. Plug it in, that is the correct answer. If it asks you to do the area, I'm going to have to think about it a little bit harder because, well, that area there is minus a quarter. It's actually a quarter, isn't it? How do I make a minus into a positive? I take the absolute value. Okay. Let's just look at it a bit more generally now, okay? If I have some function, boom, 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 I'm going to call that guy f of x. I'm going to say if I have this here is, let's say that has an area of 1. An area of 1. That has an area of, what, 3.5? Okay, and this guy here has an area of 2. In a general case, about that. If I want to do the integral, let's say this is from 0 to a. Bit of a lag there. So this is going from 0 to a. The integral of f of x from 0 to a dx, I need that dx, will be equal to 1 minus 3.5 plus 2, which will be equal to minus 0.5. Now that is absolutely correct. If it only asks you to evaluate the integral, it's a numerical answer. If it asks for the area between f of x and the x-axis from 0 to a, then that is going to be more complicated. And that's going to be the 1 plus the 3.5 and then plus the 2. So they all just add together. So then I'm going to get 6.5. Okay, if I do this in a general case, I can say, right, I've got my another function here, the same function really, is f of x. I'm going to go from 0 to, let's put in some intermediate points here, and we'll look at this property a little bit later, that you can split those. If I want the integral from 0 to c of f of x is just some numerical answer that's going to spit out. If I want the area, between f of x and the x-axis between 0 and c, I'm going to have to do, well, it's the integral from 0 to a of f of x. Then I'm going to add on the integral from a to b of f of x dx. And then I'm going to add on the integral from b to c of f of x dx. Now, so this one here is 3, this one here 2, and the first one being 1, okay? We've got a problem when we're doing area, and that is that that middle guy is going to pop out being a negative. We don't want him to be a negative, so we'll just go like that. Okay, and we can, I mean, technically, if you want to be super safe, we can absolute value all of those, but I think we only really need to for that negative guy. So we can get onto some examples now. Before we do, I'm just going to write a quick note. Area, when I'm doing area, okay, I'm going to find the intercepts. Find intercepts and take absolute value of f of x if you need to. And that's just a little tool that we're going to use. That's essentially it, guys. I'm going to run through a few examples with you as quickly as possible. So let's give it a go. Evaluate these definite integrals. Sketch the graph of y equals x minus 4 and shade. Okay. So let's just have a look at it. They're asking here from 0 to 4. They're asking here from 6 to 4. They're asking here from 6 to 0. 0 to 6, I should say. So I'll just sketch the whole thing from 0 to 6, and then we can have a look at it. X minus 4, I mean, it's a straight line. Y-intercept of minus 4, I think that's him. Is that him? Good. There's my 0. marker, there's my 4, and then 6 is going to be out here. Obviously, we're not to scale here. So, from 0 to 4, 1. This guy here is that one. So, A, or 1. The integral 0, 4, x minus 4 dx equals primitives x squared on 2 minus 4x from, where am I going from here? I'm going from 4 to 0 equals 4 squared is 16 on 2 minus 16 minus, and then I get that 0 there. That's always going to happen if you just have terms, no constant terms in here when you sub in 0. 16 on 2 minus 16, well that's 16 on 2 minus 32 on 2, so that is minus 16 on 2. Now that value comes out at negative. Makes sense. It's all underneath the curve. I could check my answer just by thinking, well, this guy's just a triangle here, isn't he? He's 4. He's 4. Half of 4 times 4 equals 16 on 2, which equals to 8, by the way. Equals to 8. Negative 8 for the integral, 8 for the area. 2 is going to be this area in here, not the area of the integral, but it will be the area as well because it's all positive. The integral from 6 to 4 x minus 4 dx equals x squared on 2. I'm repeating myself here. We could have just gone from the line straight above. From 4 to 6 equals, if I put the 16, I'm going to get 36 on 2 minus 24. Minus, well, this guy here, if I put the 4 in, he is minus, well, that's 16 on 2 minus, and that's the same answer as I got there, which is minus 16 on 2. 36 on 2, 18 minus 24 plus 8. 18 plus 8 is 26 minus 24, which is 2. Now that was a little bit complicated when we could have just looked at the triangle again. Knowing that it's all positive, we say, well, this guy's going to be a base of 2 and a height of 6 minus 4 is 2. Half by 2 by 2 equals 2, which is our same answer here. Just finally, the third part C, the integral from 0 to 6. Now I don't want to work all of that. We can just say, well, that first one is negative 8. The second one is plus 2. That'll come out at minus 6. Not the area. The area is going to be 8 plus 2, which is 10, but the integral is minus 6. Okay, now that's all we really got to do today. Just look at different properties of what'll happen. Odd and even functions. Pretty straightforward. If f of x is odd, the integral from a to minus a to a, is going to be 0. So that's just saying my most basic odd function, cubic, a minus a, odd function of symmetry, rotational symmetry, are about the origin. This area here is going to be the same as that area there. So when you integrate, they're going to cancel out. If it's even, let's look at our parabola with reflectional symmetry across the y-axis. A, negative a, this is going to be the same as that. So it's just that guy times 2. Done. We can use that to do these guys here. What's that first one? Sketch the integrals and evaluate them using symmetry. X cubed minus 4x. Looks odd, right? Let's just do a quick little sketch. Factor the x out, and I get x squared minus 4. So he cuts at 0, 2, and negative 2. If I wanted to factorize that out further, there is a positive cubic. So he's going to go like that. Now, because of symmetry, I know that this will have the same area as that. So this is negative. If that's 2, that's 2. For the integral, if that was negative 2, that would be 2. If that was negative 5, the other one would be 5. It doesn't really matter. Not going to spend the time doing that integration. You can for practice if you want. Let's move on to the next one. Even function. Here looks a parabola moved up 1. Whoop. Sorry about that parabola. From 2 to negative 2. No. Alright, so I'm just going to integrate this from minus 2 to 2 of x squared plus 1 dx. That will be equal to the primitive x cubed plus x cubed on 3 plus x from 2 to negative 2. Which will be equal to 2 cubed on 3 plus 2 minus 2 cubed on 3 minus 2. Just give us a little bit more room there. Should be enough. Which is equal to 2 on 3 is 8 on 3 plus 6 on 3 minus 8 on 3 minus 6 on 3. So you can almost see the symmetry there with the numbers. Let's just zoom out a little bit. Equals 14 on 3 minus 14 on 3. There's the two lots of it, 28 on 3. Now, I could have done this the quick way, or just a safer way, I guess. I'm going to say that that is two lots of 0 to 2. From 0 to 2. Let's go here, 2 lots of 0 to 2, x squared plus 1 dx. 2 lots of x cubed on 3. I'm doing this again. Don't need to. I've already done it. 2 to 0 equals 2 lots of 8 on 3 plus 2 equals 2 lots of 6 on 3. 18, we've already done this. 14 on 3, which is what we saw here. Next property we have here, we have already discussed. It's just the splitting of it up into different areas, A and B. I'm going to say C's in the middle there. Let's just do a quick drawing. That's all we need to do for this. You can investigate later. Boom, boom, boom. F of x, 0, A, B, C. No. They've got b there from a to b, and then we've got, well, c in the middle. It's fine. Oh, that took a bit of lag there. Interval of 0 width. Well, I mean, if I integrate from a to a, I'm not going out any distance, so I've got a area of 0. The next one's pretty handy. This is nice, reversing the integral. If I reverse the bounds, this says a to b. When I put in b to a, it's going to spit out the negative. Let's do one example. Let's just do integral. They've given us one down there, but integral of x under the line y equals x, okay, from 0 to 1. Pretty straightforward. X squared on 2 equals equals a half. Cool. Integral 0 to 1. Ooh. Actually, that's a half minus 0. Integral of 0 to 1 x dx equals x squared on 2. I'm going to reverse those bounds. Equals 0 minus, putting in the 0, then putting in the 1, and then I get minus a half. Okay, it works. That's a half. That's a minus a half. Why does it work? Just for that one example, is it? My fundamental theorem of calculus, which we can look at a previous video for, says that if I take the integral of a function from a to b dx, that equals to the primitive when, oh, sorry, I'll just get rid of that there. The primitive when b is subbed in minus the primitive when a is subbed in. If I reverse these, let's just see what happens. Dx equals the primitive when a is subbed in, it's the primitive when b is subbed in. Take out a negative, negative, the f of b will become a positive, minus the f of a minus and a minus is a positive. And that is equal to the negative of the original. So it works with the fundamental theorem of calculus. Next, and then I think we might be done. Evaluate and compare these two definite integrals using the fundamental theorem. Straight away, I can just see that one's going to be the negative of the other. Integral for 2x minus 1 dx. Could just draw a triangle or trapezium. Let's just integrate it. It's fun. Super fun. Minus x for 2. Sub the 4 in. And I'm going to get 16 on 2 minus 4. Sub the 2 in, minus 2 squared on 2 minus 2 equals 8 minus 4 is 4 minus 4 on 2 is 2 minus 2 is 0, which is 4. So my answer for B is going to be negative 4. We'll look at how that works graphically a little bit later. Integral of a sum. We've already kind of done that, okay? This is just definition stuff. I can split my integrals if it's two functions, I'll do that. Which one's going to be easier? Obviously the first one. I'd say this might become useful in some other questions, but they're equivalent. A constant can be ripped out the front. That k, so this holds true. Again, a little bit of a lag there. These properties you can investigate, but there we go. Boom. That's pretty much enough for today. So, thank you very much. I will see you next time. Ciao.